So today I have a Conrad Johnson MV-60 amplifier in here. So let's take a look at it. It's a tube amplifier. Here's the back of it. Power input, speaker terminals, audio input, and the other set of speaker terminals. So let's go ahead and pull the top on it and take a close look inside. Alright, so here's some shots of the inside of the unit. Audio output transformer, filter capacitor, the main AC input transformer, the other filter capacitor, and the other audio output transformer. Let's look at the bottom. So back here are the audio output transformers, the main power transformer, the filter capacitors. And then up here, there's one main circuit board for everything. Look at that. So just upon doing a visual inspection, one of the first things I noticed was it's got those two filter capacitors right there. SN150NJ. That one's the same, but look at the color difference between the two. That shouldn't be. At least I don't think so. Well, unfortunately, they didn't make it so that I can look on the other side of the circuit board without having to tear the board out of the unit completely. So yeah, there's no access to what's on the other side of the board where all those diodes are. Well, looking at the circuit traces, it looks like it's maybe a mirror image of the two. That might not even be the whole problem. Like I said, I haven't even hooked it up yet. I'm just doing a visual inspection first. Okay, so I went ahead and applied power to the amplifier. I do have speakers connected, and I can see the output tubes. I have good filament on both of those. But as I'm looking at the driver tubes here, I see no filament on the driver tubes or on the preamp tubes. And I see this preamp tube has lost its silver coating on the inside. I'm not sure what's going on with that. I'm not sure if the tube might be cracked. A lot of times when air gets into these tubes, that silver coating will actually turn white. It just looks like it never was coated from the factory, but I don't see any filament on either of the driver tubes or either of the preamp tubes. So I'm going to have to go ahead and check, do a little circuit tracing and find out what's going on, why we're not getting the filament voltage on those tubes. Alright, so here is a close-up view of the preamp tube, the one that has lost its coating, and I thought I would just do a quick visual inspection. And so I'm looking at it, and what do I see right there? There's a crack. So definitely this tube is not vacuumed anymore. There's the other half of the crack. Something's happened to it right there. Maybe it took an impact, I'm not sure. But definitely got a problem with that. So I thought I would take a look at this fuse. It's a 4 amp slow blow fuse, and it's open, but it doesn't look like it's been damaged at all. Okay, so here's a close-up of the fuse. It doesn't look like it's been blown violently, but I noticed that if I try to turn it, it takes just the slightest amount of force to turn, and so that tells me that it's not really being retained with any kind of surface contact, because I can just barely move this thing and it turns. Also, if I remove the fuse, it pops out really super easily, And if you look at the ends of the fuse holder, it's been extremely hot. Look at that solder. It's melted the solder away on both ends. So I don't think the fuse blew because of an overcurrent situation. I think the fuse blew because of an over temperature situation. Like I said, if you look at the fuse, it's perfectly fine. I don't see any of the windings blown, but I do see a telltale sign on this very end right here of discoloration where it's been too hot. So I'm going to go ahead and put another fuse in here. I'm going to retension the contacts and resolder the contacts as well. So looking at the fuse holder diagonally, you can see some arcing going on right in here and a lot more arcing on this side. So that tells me that it didn't have good electrical contact. So heat was probably being generated between the fuse ferrule and this fuse holder. So I'm just going to take this and squeeze it together so we have a much tighter contact of the fuse. And I'll do the same thing to this side. Just squeeze it together, and so we should have a much better fuse contact at this point. So I'm going to go ahead and resolder this right here because I see a bunch of cracks and that can lead to heat and high resistance. So I'll do both fuse holders. Also, if you take a look at the old fuse on the bottom and the new fuse on the top, you can see a definite color change. The old fuse has a much more orange brownish color to the glass than the new fuse does. Once again, that tells me it's been overheated. And of course, looking at this telltale sign right here, this brown mark tells me that it's been overheated. Okay, so electrically we should have a good fuse holder contact to the circuit board. The soldering looks really good now. No more cracks, no more cold solder joints. It's funny they call it cold solder joints when it was caused by overheated solder. But nevertheless, I've retensioned the contacts and I've resoldered the fuse holder. So let's go ahead and pop the new fuse into it now. Definitely much more contact area, and now that I've retensioned it, I can just barely turn it. Well, let's go ahead and fire it up and see if we get any filament on those tubes now. Okay, well, as you can see, I have filament on these tubes now. This one's going to be kind of hard to see, but I can assure you I hear audio out of the left channel. I'm not going to get anything out of this channel because the tube has lost its vacuum. It has air in it, so it's not going to operate properly. So I'm still going to need to replace that tube, but I do believe that the contact resistance was the issue that blew that fuse. I actually could measure current across that fuse holder, and so let's go ahead and do that. I'll put the Fluke 117 in the current mode. We'll flip this unit back over and see how many amps is actually flowing across that fuse. It hasn't blown the fuse yet, and like I said, it didn't blow the old fuse. I believe it was a contact resistance issue. So let's go ahead and do that right now. And then I'll go ahead and get another preamp tube on order, and this thing should be up and running, no problems at all. Okay, so as you can see, I have some very short test leads. These things are only 13 inches tip to tip, and so the wire length is only about 10.5 inches. And so that makes for a very low resistance contact for accurate amp meter readings. And so I have my voltmeter here set up in the AC amp range, and I'm on the 10 amp scale. And so I've got my variac turned up to 125 volts AC. The unit's been off for about 15 minutes now, so it should be cold. I'm going to go ahead and just flip the power switch on. I'm going to put this in min-max. And so we can actually go back and look at the maximum current that's going to be flowing across this fuse on a cold startup. Okay, so here we go. Contact. So I saw just over 4 amps. I saw 4.13. And so max actually shows me 4.17. And so I do have audio going into the unit, and I can hear some audio coming out of the speaker right now. It's not YouTube copyright free audio, but it is low level audio, so it shouldn't be a problem. I just want to let this run for a minute or two, let the tubes warm up and see what the average current is. So right now we're looking at about 2.75 amps, once again, which is why they chose a 4 amp slow blow fuse. So I think we're going to be okay. Okay, so I went ahead and pulled that capacitor off the board, the one that was brown like it'd been hot. And so I'm going to do a resistance check on it to make sure it doesn't have any leakage. And it's over 40 million ohms, so I'm going to say that's okay. Let's reverse the leads on it. Charge it the other direction. And once again, over 40 million ohms. So let's check the capacitor value. We'll put it over here to the diode range and see that capacitor logo right here. If I press the yellow button, it's going to put it in the capacitor range, and it measures 151, 152 nanofarads, and the capacitor is rated at 150 nanofarads. So I'm going to say that is perfectly fine. Alright, so my customer has sourced me a 12AX7, although it's not in the original box. Let's go ahead and take a look and see what's inside. 12AX7, and it is a Dynaco, made in West Germany. Alright, let's go ahead and pop it in. There we go. We'll get some speakers hooked back up to it, and we'll give it a test. Okay, here we go. Contact. Power's on, tubes are warming up. Got some YouTube copyright-free audio playing through it. Well, it's working great. I get both channels now. It works excellent. So it tells me if I want to bias the output tubes, I should let it warm up for at least half an hour before I try to bias the tubes. So I think I'm going to go ahead and do that. I'll just put it off to the side, work on something else, let it warm up, and we'll come back to it and do a real quick bias setup. Okay, so here we go. It's been warmed up for a while. I'm just going to go ahead and insert my screwdriver. I'm going to turn it clockwise until the LED just lights up, and then back it off until it just goes off. I'll do that with all 4 tubes. Now we'll start some more copyright-free audio. Just had a blown fuse due to contact resistance. I don't think there was actually anything wrong with the unit other than the contact resistance. And also, I had a cracked tube. I don't know if it got bumped or dropped or the customer just didn't notice it was cracked. Not sure. Anyhow, he supplied a replacement tube. It's working absolutely perfectly right now. All right, there it is, back together. Let's play some YouTube copyright-free audio. You can definitely see the tubes lit up now. Those were always lit up, but these were not. We didn't have any filament voltage on these tubes whatsoever, and now you can clearly see that they are lit. Well, I certainly hope you enjoyed this video on the Conrad Johnson MV-60. Please consider subscribing to my channel and liking this video. It really helps my channel grow. Remember, with your help, we can keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. You can contact me on social media, Facebook, Instagram, Twitter at NorCal715 or at NorCal715videos@gmail.com. Once again, I really appreciate you watching this video. Everybody have a great day. Thanks so much for watching. Bye-bye.